All right, guys, today we're going to be going over our force notes. Now, I know normally when we do notes, I give you a copy that you can put into your notebook. I'll get you that whenever I get back. So, right now, we're just going to watch the notes. Make sure you're paying attention. The Nearpod's going to pause and ask you some questions, and then you're going to have a quiz after. So, make sure you are listening for the notes. Okay, so we're going to be going over force, right? That's what we've been covering all in this unit. Everything has been going over force. So, a force, along with energy, make it possible for us to do work. So, there are three forces that we cover in fifth grade. We have magnetism, friction, and gravity. So, first of all, a force is a push or pull. So, in this picture, we have some forces right here. We have gravity pulling everyone down, keeping them on the ground, or if in the air. If they are in the air, gravity is going to pull them back down. So, if you see the girl jumping, doing the jump rope, her body pushes down on the floor with a force, so then she can jump up off the floor. The kids are also pushing on the handles of the rope to hold it. So those are some forces we see in the image. Now, we have equal forces, which we've already talked about, right? When the forces acting on an object are equal, an object's motion will not change. Now, you also may hear the word balanced force. That's why you kind of see how the yellow is actually yellow equal is, or the red equal in the yellow box. It's actually over the word balance. Balance and equal pretty much mean the same thing. So if you hear balance forces, it means the same as equal. So again, what do we know about equal forces? We know equal forces cause no motion. So an object's motion will not change. So like this soccer ball right here, right? It actually has equal forces acting upon it. Gravity is pulling it down with some amount of force, and the ground, is pushing back up with that same amount of force, so the ball does not move. Now we also have unequal forces. So when the forces acting on an object are unequal, the object's motion will change. It will start to move, change its position, go faster, slower, turn, something like that. So right here we have this ball, and you see it being kicked into the goal. Okay, right? It's supposed to show motion of the ball going into the goal. Okay, now just like whenever we have equal forces, and you may hear balanced force, that's a synonym, they mean the same thing. You may hear unbalanced forces. And that actually starts in sixth grade, but some of the readings or videos you may watch may say balanced and unbalanced instead of equal and unequal. They're the same thing, they mean the same thing, so don't be confused. Just know that balanced is the same as equal, and unequal is the same as unbalanced. Unequal forces can cause an object's motion to stop. So, whenever forces are unequal, it can actually cause a moving object to stop. It can cause an object to start moving. It can cause an object to speed up, slow down, or change direction. So, any of those things can be caused by unequal forces. So, let's look. So, real quick, you're going to get a question on this. Is it equal or unequal? So, how would you describe the motion? So, right here we have a picture of a six people playing tug of war, three on each team, and the rope is perfectly in the middle. So there's no movement there. So do you think that that would be an equal or unequal of force? All right. Hopefully you picked equal force. They're both pulling the rope with the same amount of force. The rope is not moving, so that's how we know it can be an equal force. What about and they're both pulling that rope as well. And then we have the soccer player. So again, you're going to go ahead and answer. He kicked the ball. Is that an equal, unequal force? Is it a push or pull? So go ahead and answer the question. All right. Hopefully you picked unequal force. His foot kicked the ball, causing it to go in motion. So we know there was an unequal force acting on it to make it move. And then he pushed the ball away from him by kicking it. All right. So one force we look at in fifth grade is magnetism. Now we've already dealt with magnetism, so now we've looked at it more just as a physical property. Is an object magnetic or not magnetic? But we also need to know that magnetism is a force. So if something is magnetic, it will push or pull things, other things towards it. Or a magnet will push or will pull magnetic things towards it. Now, if you have two magnets, magnets actually have two sides. They have a north and a south. Okay. Now, the opposite sides attract. So if you hold the south end to the north end, those two sides will attract, right? If you've ever heard the phrase opposites attract, you can think about that. It goes with magnets. And then the alike sides actually push away from each other. They do not like to touch, right? So if you've ever, I'm sure you've done this, you've tried to hold up two sides of a magnet and they did not want to touch. It's kind of a weird sensation. You like try to push them together and it's like there's some, imaginary force there. Well, it kind of is. It's magnetism that is keeping those two objects away from each other. So there's a push. So magnetism can cause push or pull. Now remember, the only objects that will actually the only objects that a magnet will pull towards it are magnetic objects. So magnetic materials would be those things that are made of steel, iron, nickel, and cobalt. So we've covered that a lot already. Now, I'm not sure if you knew this or not, but magnetism is pretty much used all around you as a force. So doorbells are used for magnetism. Credit cards actually use magnetism, and so do wind turbines. A lot of these things use magnetism to do it, and they use something called electromagnets. That's kind of a little more advanced, but just know that magnetism is being used in a lot of different things. All right, another motion or another force that we go over is friction. So friction is a force that resists motion. So anytime two surfaces rub against each other and an object is trying to move or is moving, that will cause some friction, right? And friction stops or slows down. The more friction, the more that object's going to be stopped or slowed down. The less friction, the faster that object's going to be able to go, or the farther distance it's going to be able to go. So friction causes motion to slow or stop. Friction is a contact force. This means two objects must touch for friction to have an effect. Friction is the force responsible for shaping Earth's surface. So usually if we're looking at a surface to know how much friction it's going to have, because some surfaces have a lot more friction than others. If we have a rough surface, so if you kind of rub your hand across a surface and it's kind of bumpy and rough, then we expect it to have a lot more friction. Whereas if you rub your hand against a surface and it's very smooth, then you expect it to have a lot less friction. So ice, for instance, very smooth, especially if it's cleaned and everything, there's nothing on it. That surface is going to be very smooth. So that's why it's used for things like ice skating, right? Because it has very little friction. Same for like skiing and things like that. The snow, very smooth. And if it's good snow, it'll be very smooth. And then some surfaces like roads are very rough, right? If you go and put your hand on a road, it's probably maybe not the safest thing to do, but if you've ever felt the road or felt the sidewalk, they usually are pretty rough. Why are they so rough? Well, we want them to have a lot of friction, right? We don't want them to be like a ski rink, because on a ski rink, if you stop, and you'll just keep going. Like if you stop pushing yourself forward, you'll keep going unless you cause yourself to stop. But on a road, we don't want that to happen. If you stop and put on your brakes in a car, you want to stop as quick as you can. So sometimes we want more friction, sometimes we want less, depending on the activity or the thing we're doing. So like for instance, right here we have some sandpaper, which is very rough, and a wooden floor. That's going to create a lot of friction. Right here we have a hockey table. So we have this very smooth hockey table, so the puck can go across it very easily. So that hockey table is going to be very smooth compared to the sandpaper is going to be very rough. So high friction on the sandpaper, low friction on the air hockey table. So friction, you can use glasses. That's why a lot of your washcloths and things like that are kind of bumpy and they're not very smooth. That way they can help you wash the dishes. They can pull off some of those surfaces, the dirty surfaces on your dishes. Weathering of rock, transportation, all uses of friction. Another force we talk about is gravity. So gravity is a force of attraction that pulls down objects towards the center of Earth or any other body in space. So the moon has gravity too. The sun has gravity. All the planets have gravity. So it's not only Earth that's special there. Just really anything very, very large, you'll be able to feel its effect of gravity. Because the Earth is so big and we're so much smaller, Earth's gravitational pull is very strong. It's what keeps us and everything else on Earth, unless we, jump, but eventually we'll get pulled back down. So uses of gravity, we can use things like satellites and other spacecraft. Our moon, the reason our moon stays around us is not because it likes us and it's our friend. It's because Earth's gravity keeps the moon around it. We can also use it for hydroelectric dams. So here's a question that you're going to answer in the Nearpod. How are gravity and friction at work when you're testing paper airplane designs? So here's an answer you could put. We are using friction to fold and hold the paper airplane. So if you didn't have any friction between your hands, your fingers, and the paper airplane would just slide and fall right out of your hand. Friction is also happening when the air pushes against the plane as it moves through the air. So friction can also be caused by air. I believe it's called drag, maybe, but even air there can be friction in air. So if you run, the air is hitting you, the air is rubbing against you. That is friction. Gravity is also pulling us and the paper airplane in this situation. So, all right, now we also have something called energy transfer. So energy transfer, remember, if we think what happens when things bump into each other. So maybe one or two things are both moving. What happens whenever one object bumps into another, or we call it collide. So like right here, the person who's playing soccer, they're kicking the ball. So the foot collides with the ball. Or bumper cars, the bumper car collides with each other. Or the two cars right here, they collide with each other. So what happens with the energy from one car to another? So first of all, what is energy? Well, energy is just anything that makes things move or makes them work. So energy can cause things to move. Force is the push or pull that we can cause energy. So right here, we have this person, they're using energy to move the ball. They're pushing it. So they're using a force up to push it, and that force is caused by the energy they're giving. And then right here, it starts to roll, so we know a force is acting on the ball. That would be gravity, right? And then right here, we have someone flicking one marble and it's going to hit another one. So the energy is going to transfer, and then it's going to go down here and we're going to see the energy transfer from one marble to another. So can energy be transferred? Well, of course, we've already talked about it. So yes, energy can be transferred from one object to another when objects collide. Some of the energy may be transferred into heat or sound, but most of the energy is transferred from the object with the most energy to the object with the least energy. So sometimes whenever objects collide, like a pull ball and a pull stick, the energy's transferred from the pull stick to the ball. But some of the energy goes into making sound energy, and some of the energy goes into making heat energy, right? But most of the energy is going to be transferred into the push and then transferred to whatever objects collide. Or if there's a car wreck, right, very loud, so some of the energy is transformed to sound, but also most of the energy is transferred from the one car to the other car. So what do we kind of notice about some trends in energy transfer? The object with the more energy or object with more energy will transfer to the object with less energy. The more energy in an object, or the more energy an object has, the more energy it will transfer. So if you have a car going very, 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 very fast and it hits another car, hopefully no one's in there, but it hits another car, it'll transfer a lot of energy to that car, right? Or if you have a car going very slow and it bumps into another car, it'll transfer not as much energy, okay? And it's all energy transfer always occurs from whatever had more energy to whatever turned less, okay? And we're talking mostly about collisions here. So an object will be either will be traveling, will be going, and then it'll hit something else and push its energy into something else. So that is going to be the end. Make sure you answer the questions in the Nearpod, and no notes. I'll give them back to you whenever I get back on Thursday. So we'll glue those in on Thursday.